Hi, this is Jim with Shiloh Kahal, and I'd like to do a video concerning the book of astronomy in First Enoch, chapter 72, and the working of the sun, and to a lesser extent the moon, but primarily the sun. And I want to illustrate it using a wonderful video by George Nuber of GeoTruth, along with Stellarium and a couple of Stellarium-based models that really are the same type of modeling, but two different people and two different messages. But I would like to show those to you as well, and then just basically illustrate to you how the Book of Astronomy and First Enoch works on in biblical cosmology. So let me start first, though, for those who might not be familiar with the Book of Astronomy through in First Enoch. Let me start first by just reading to you chapter 72 of First Enoch before we get started. But let me also first explain. I'll be reading from the Yah scriptures, and in the Yah scriptures, in that translation, they replace the word heaven with Shemaim, which is the English word for the Hebrew word for heaven. So you'll be seeing Shemaim throughout and hearing Shemaim throughout what I read to you here. But when you hear Shemaim, uh, in most of your translations, you would be reading heaven. Thanks. The Book of Astronomy, Chapter 72. The Book of the Courses of the Lights of the Shemaim, the relations of each, according to their classes, their dominion and their seasons, according to their names and places of origin, and according to their months, which Uriel, the Kodesh messenger, who is with me, who is their guide, showed me. And he showed me all their laws exactly as they are, and how it is with regard to all the years of the world and unto everlasting, till the new creation is accomplished, which endures till everlasting. And this is the first law of the lights. The light, the sun, has its rising in the eastern portals of the Shemaim, and its going down in the western portals of the Shemaim. And I saw 6 portals in which the sun rises, and 6 portals in which the sun goes down, and the moon rises and goes down in these portals. And the leaders of the stars and those whom they lead, 6 in the east and 6 in the west, and all following each other in accurately corresponding order. Also, many windows to the right and left of these portals. And first there goes forth the great light, named the sun, and its circumference is like the circumference of the Shemaim, and he is quite filled with illuminating and heating fire. The chariot on which he ascends, the wind drives, and the sun goes down from the Shemaim and returns through the north in order to reach the east, and is so guided that he comes to that portal and shines in the face of the Shemaim. In this way he rises in the first month in the great portal, which is the 4th. And in that 4th portal, from which the sun rises in the first month, are 12 window openings, from which proceed a flame when they are opened in their season. When the sun rises in the Shemaim, he comes forth through that 4th portal 30 mornings in succession, and goes down exactly in the 4th portal in the west of the Shemaim. And during this period, the day becomes daily longer, and the night nightly shorter to the 30th morning. On that day, the day is longer than the night by a 9th part, and the day amounts to exactly 10 parts, and the night to 8 parts. And the sun rises from that 4th portal, and goes down in the 4th, and returns to the 5th portal of the east 30 mornings, and rises from it and goes down in the 5th portal. And then the day becomes longer by 2 parts, and amounts to 11 parts, and the night becomes shorter and amounts to 7 parts. And it returns to the east and enters into the 6th portal, and rises and goes down in the 6th portal 31 mornings on account of its sign. On that day, the day becomes longer than the night, and the day becomes double the night, and the day becomes 12 parts, and the night is shortened and becomes 6 parts. And the sun mounts up to make the day shorter and the night longer. And the sun returns to the east and enters into the 6th portal, and rises from it and goes down 30 mornings. And when 30 mornings are accomplished, the day decreases by exactly 1 part and becomes 11 parts, and the night 7. And the sun goes forth from that 6th portal in the west and goes to the east and rises in the 5th portal for 30 mornings, and goes down in the west again in the 5th western portal. On that day, the day decreases by 2 parts and amounts to 10 parts, and the night to 8 parts. And the sun goes forth from that fifth portal and goes down in the fifth portal of the west and rises in the fourth portal for 31 mornings on account of its sign and goes down in the west. And on that day, the day is equalized with the night, and the night amounts to 9 parts, and the day to 9 parts. And the sun rises from that portal and goes down in the west, and returns to the east and rises 30 mornings in the third portal, and goes down in the west in the third portal. And on that day, the night becomes longer than the day, and night becomes longer than night, and day shorter than day, till the 30th morning, and the night amounts to exactly 10 parts, and the day to 8 parts. And the sun rises from that third portal and goes down in the third portal in the west and returns to the east, and for 30 mornings rises in the second portal in the east, and in the same way goes down in the second portal in the west of the Shemaim. And on that day, the night amounts to 11 parts, and the day to 7 parts. And the sun rises on that day from that second portal and goes down in the west in the second portal and returns to the east into the first portal for 31 mornings and goes down in the first portal in the west of the Shemaim. And on that day, the night becomes longer and amounts to the double of the day. And the night amounts to exactly 12 parts and the day to 6. And the sun has traversed the divisions of its orbit and turns again on those divisions of its orbit and enters that portal 30 mornings and goes down also in the west opposite to it. And on that night, the night is decreased in length by a 9th part, and the night has become 11 parts and the day 7 parts. And the sun has returned and entered into the second portal in the east and returns on those, its divisions of its orbit for 30 mornings, rising and going down. And on that day, the night decreases in length, and the night amounts to 10 parts, and the day to 8. And on that day, the sun rises from that portal and goes down in the west, and returns to the east, and rises in the third portal for 31 mornings, and goes down in the west of the Shemaim. And on that day, the night decreases and amounts to 9 parts, and the day to 9 parts. And the night is equal to the day, and the year is exactly, as to its days, 364. And the length of the day and of the night, and the shortness of the day and of the night arise. Through the course of the sun they are separated. So it comes that its course becomes daily longer and its course nightly shorter. And this is the law and the course of the sun, and its return as often as it returns 60 times and rises. The great light which is named the sun forever and ever. And that which rises is the great light, and is so named according to its appearance, according as Yahuwah commanded. As he rises, so he goes down and does not decrease, and does not rest, but runs day and night. And its light is sevenfold brighter than that of the moon. But as regards size, they are both equal. Okay, so what we just saw in First Enoch is the existence of 6 portals through which the sun traverses. Uh, it, it starts in the fourth portal, moves into the fifth portal, moves into the sixth portal, turns around, comes back through the sixth portal, comes back through the fifth portal, through the fourth portal, into the third portal, into the second portal, through the first portal, turns around, comes back through the first portal, through the second portal, through the third portal again to complete a year. And in that description of Enoch, first Enoch, there we also saw, as we witness, the constant in the first part of the year, the constant lengthening of the day compared to the night, and it's expressed in terms of parts. And then once the sun makes its way back to the fourth portal and enters the southern hemisphere, then we begin to see the night exceeding the day. So my original plan was to demonstrate First Enoch 72 in Stellarium, and I still plan to do that. But I also, as I was working on this, came across some excellent work by George Nuber of at GeoTruth. That's his YouTube channel, and he's put out something that really does an excellent job of demonstrating this as well. So I'd like to go there first before we go off to Stellarium. So here is the video that I'm going to show you here in a second, just to make sure everybody knows the gentleman that produced this. His name is George Newber, and this is his YouTube channel, GeoTruth. I subscribe to him, and I would suggest you do as well. He's got wonderful information that, to my knowledge, there aren't too many people with this skill set and ability to discuss some of the cosmology uh, topics and issues that need to be addressed out there. So I would like to show you what he put together here because it really is just an excellent, and there's no sound in it. To my knowledge, I didn't see any sound. He ends up just speaking, like you can see in the top of this video where he says the sun's location at day 1 of month 1, head of the year, which would be right around the spring equinox each year. Uh, so I'm going to pause as we go through this to illustrate as this goes through and to speak some of the things that he's saying and relate it back to what we saw in First Enoch. So George's work does not need me to explain what he's doing, but I would like to just quickly see if I can, in case folks are not familiar with what they're seeing here, I would like to speak to it a little bit before we let his video run and let him show you what he is doing with his work here. So if in biblical cosmology, we have the circle of the earth as we see portrayed here. Here is the circle of the earth. In the outer rim, this would be like the Antarctica up here in the wall of the Antarctica, the outer rim of the Earth's circle with the firmament uh, affixed to the the outer edges of the earth. And then we have in the center of this circle would be the North Pole, or the North Star, Polaris, exact north to this circle. And in uh, down here is a black line. I don't know if you can see it, but there's a black line that runs around this circle, and to the outer side of this blue line, which is the fourth portal, which I'll explain in a second. That black line is the equator. I don't know if you can read that, but that reads the equator. And in his illustration, he's going to start. This yellow dot is the sun, and he's going to start from there because he's going to basically run us through First Enoch 72. So to the north, everything on this side of the equator, this is the northern hemisphere, and everything on this side is the southern hemisphere. When we begin, the sun is going to start by making a circle. It's going to run a circuit, a circle around the earth each day. It's going to run clockwise, and each day, as we begin the first of the year, the sun will be moving north, moving towards the North Pole here. Each day getting a little bit closer with each day approaching the north. And it will continue to move north as it makes its way. And I'll just, I'll explain in a second here. So it will make its way north until it reaches this Tropic of Cancer, at which time it turns back around and starts heading south, crosses the equator into the southern hemisphere, continues to run south till it reaches the Tropic of Capricorn here. And this is the Tropic of Cancer. If I failed to tell you, this black line up here, this is the Tropic of Cancer. This is the northernmost circle that the Earth is going to run. And then down here, as we run south, it's going to hit the Tropic of Capricorn, which will be the southernmost circle that the sun will run. And once it reaches this Tropic of Capricorn, the sun is going to reverse its course again and begin heading north to cross the equator. So just a couple quick notes here. Enoch speaks about what's happening to the length of day and night. And as the sun moves north, the day lengthens and the night shortens until, well, here where it starts, we have equal day and equal night because the sun is located on the equator here. But as we move north, the day lengthens and the night shortens until we reach the Tropic of Capricorn, and the day is exactly twice the length of night. And then once the sun turns around and starts heading back, then we just reverse the pattern of the days. The days continue to get shorter and the nights begin to lengthen until we get to the equator again, at which time we have equal daylight and equal night. In other words, same length of day and same length of night. But as we enter the southern hemisphere and the sun continues on its circuit, as it moves to the south, daylight, the day becomes shorter and the night becomes longer with each day that passes until we reach the outermost part of the sun's circuit, which would be the Tropic of Capricorn, and at which time the sun turns around. And at that point in time, the night is exactly 2 times or double the length of the day, or of the daylight. And then once it reverses its course and begins heading north again, then we reverse the course of the night and day split, and the night begins to shorten and the day begins to lengthen until we reach again the spring equinox once again, and the sun is over the equator and we have equal day and night. So he is going to portray what I'm going to continue sharing here, but I'll quickly explain. So he is positioning the sun here at the entrance to what Enoch calls the fourth portal. Day one, and this begins the beginning of the year, day one of month one. So we begin in the fourth portal. And what we have here, you'll see a line on the outermost part of this blue shaded line is the equator, and that's our starting point. But as the sun moves north, it takes 30 days for the sun. Each day it gets a little bit shorter. It takes 30 days for the sun to make its way north to reach this second line here. So it takes 30 days for the sun to move as it moves north a little bit every day. It takes 30 days for the day to reach the sun to reach this line here, at which time it leaves. And let me also back up here. Blue, uh, this blue shaded portion, this line here at the equator to this next line, this would represent the fourth portal of Enoch. So the sun spends 30 days in the fourth portal. Then once it at the end of 30 days, it leaves the fourth portal and enters this next portal that runs from this line to that line, and that's the fifth portal. And then it takes another 30 days for the sun to run from this line to that line, which is the sixth portal, but actually it's counted as 31 days because when it hits the Tropic of Cancer and turns around, there's an intercalary day that gets added to it. So we end up in that third month. We have a 31-day month as it turns around. That extra day, or that 31st day, is considered the intercalary day. Then the sun begins heading south again. It's reversed its course. It's heading south. It takes 30 days to go back through the sixth portal, 30 days to go back through the fifth portal, 31 days to go back through the fourth portal because of the intercalary day when we hit the equator again. And then we're going to have 30 days as we then move from this line to this line. This will be the third portal. And it takes 30 days to go through the third portal. Then between this line and this line is the second portal. It takes 30 days to get through the second portal. From that line to this line is the first portal. And it takes 30 days, but really 31 is counted because we have the intercalary day, where the sun reverses its course and heads back through the first portal for 30 days, then back through the second portal for 30 days, back through the third portal for 31 days, but then we have the intercalary day, 31 days because we have the intercalary day. And that completes the course of the sun throughout the course of a year, which is measured to be 364 days, according to Enoch. And one more thing I'd like to point out before I begin running his video here is George gives us a lot of information, and he's going to be measuring for us the height of the sun. He will give us the height of the sun above sea level, and he will also be giving us the speed of the sun as it circles clockwise, because clearly as the sun moves north, the length of the day doesn't change, but so the speed of the sun has to change in order for each of these days to be equal, because it's traveling a smaller distance. And as we in the northern hemisphere, as we head north, you're going to see the speed of the sun slow down, and then as it turns around, it's going to start speeding back up again. And then once it passes the equator, it's going to speed up even more, because it's got to keep speeding up until it gets to the Tropic of Capricorn, at which point it's reaching its maximum speed and then begins heading back north and will start slowing down again. So he's going to be giving us this kind of information. I'm not sure I'm going to be able to really track. I think it's very interesting, but I'm not probably going to be able to track it here. I'm more interested in just outlining for this video, more interested in outlining what he's doing up here, which will be measuring the sun going through the portals each of the months until we complete a year. So I'm going to go ahead and start the video now and let you watch what he's done. Okay, I'm getting ready to hit play, and we're starting with the sun's location at day 1 of month 1, which will pretty much be the spring equinox, which is usually right around 320, 319, 321 of each year, and that is the head of the year according to first Enoch. So let me go ahead and start the video here and see if I can pause it as he makes moves. Okay. So he is showing the sun has taken on day 30 of month 1, the sun's spiral movement has moved through the 4th gate. So he has, or the portal, he's using the word gate, and I think it depends upon what version you're reading, but if I may use gate and portal interchangeably, but he just measured the sun moved from the outside of the equator here to this line here, which means that it just went through the 4th portal for 30 days, and now it's leaving the 4th portal and getting ready to enter the 5th portal, and the sun has slowed down. Looks like I think the sun is pretty much the same height there, but okay, we'll keep going. Okay. Now he has shown, and now he's moved. Here's the equator, this black line here, and he has now moved the blue line from the 4th portal to the 5th portal here, and this blue line, this shaded area would be considered a representative of the 5th portal or the 5th gate, and the sun has just traversed through it. It had left the 4th portal, which was here, entered the 5th portal, and spent 30 days here. And we're ending day 30 of month 2. Sun is still at 3,107 miles high, but the speed of the sun has slowed down to 1345 here. So let's go ahead and run forward. Okay. Now he has just moved the sun forward 31 days, because we're into the intercalary day. Every 3 months we get that 31 days. And so now we're seeing what he's shading here would be considered the 6th portal. And he just traveled at the beginning of this sun moving north through the 6th portal. It was heading north. We're going to see it took 31 days to reach the northernmost part the sun's going to travel, and then it's going to turn around and start heading south. So it just went north through the 6th gate. It's getting ready to turn around and begin heading south through the 6th gate. The sun is still 3,107 miles high, but the speed of the sun has slowed down to 1,203 miles, and that should be, I believe that'll be the slowest that the sun moves throughout the year. Okay, let's go to the next gate here. Okay, so he has just portrayed the sun having turned around after 31 days going north in the 6th portal. It has turned around and spent 30 days going back through the 6th portal to end the 4th month here. And the sun is still at 3,107. The sun is sped back up to 1345. And now we'll watch it go through the next portal here. Okay, so we have just gone through the 5th portal for 30 days. The highlighted in blue, and the sun's headed south. It's heading it toward the outer rim, towards the southern hemisphere. In fact, shortly we're going to cross this line and end up in the southern hemisphere. The sun is still 3,107 miles high, and the speed is back up to 1,486 miles an hour. And now the sun is getting ready to go back through the fourth gate, and I believe we're going to spend 31 days in the fourth gate or fourth portal here. Okay, so the sun has just traversed through the fourth portal. And because we've reached the equator again, we have the intercalary days. So we've got 31 days here. We also have what we would call the fall equinox. We're back to equal day, equal night at this point in time. This would be right around 9:20, 9:18, 9:19, 9:21, depends on the year here. The sun's still 3,107 miles high. Sun is circling clockwise. Now we've sped up to 1627. Now the sun's getting ready to go into the southern hemisphere for the first time of this year, the second half of this year. So let's watch what the sun does. Okay, so the sun has just traversed through the third portal, which is now portrayed by this shaded line here, the third portal. It's traveled for 30 days to the outer rim of the 30th portal. I'm sorry, third portal, and getting ready to enter the second portal. The sun is still 3,107 miles high, and now it has sped up to 1,768 miles an hour. All right, we'll watch it go through the second portal here. Okay, so now the sun has gone through the second portal, which is represented now by this blue shaded area. We've gone 30 days. We've gone through the second portal. We're getting ready to enter the first portal, which it will spend 31 days because of the intercalary day in a moment. You'll see that in a moment. And the sun is still 3,107 miles high, but the sun has reached the speed of 1,909 miles an hour, the required speed to traverse this radius circumference in a day's time. So let's move through the first portal here. Okay, so the sun has just traversed through the first portal for 31 days because this is the intercalary month, and as the sun is turning around, now it's gone as far south as it's going to go, and the sun remains 3,107 miles high, but the speed has reached 2,051 miles per hour, which will be the fastest the sun goes, because from this day forward, which is also considered the winter solstice, because this will be the longest night of on this day at this time. The night will be exactly double the day. It'll be the shortest day of the year. Okay, so now the sun's going to begin making its way north again, and we're in the fourth quarter of the year. And it's headed back through the first portal, but headed south this time, or north this time instead of south. Okay, so it just traversed the first portal heading north and reached the second portal, spending 30 days here. And it's getting ready to enter the second portal and stay there for 30 days. The sun is still 3,107 miles high, and the speed is down to 1,909 miles an hour now. Okay, we'll go through the second portal. All right, so the sun has just traversed the second portal for 30 days, and it's getting ready to enter the third portal. The speed of the sun is down to 1,768 miles an hour. The sun height still remains at 3,107 miles high. Okay, so we're now getting ready to go through the third portal, and we're going to see 31 days counted again, because that will be the intercalary day, and we will be completing the year, and that's what's happened. So we just finished traveling through the third portal or the third gate. And this month will be 31 days, and we will be entering what we're calling the spring equinox again, and that will have completed our 364th day, which is what George is telling us here. Sun stayed at 3,107 miles high. The sun's speed is back down to around 1,627 miles an hour, and that was the last day of the year. We've completed our 364th day of the year. Now, let me just go forward here and see that concludes really what I would share with what George has illustrated here against first Enoch. But let me go forward here a little bit and see if there's something else he wants to share. Okay. So he's got a chart. I wonder if I forgot about this. And this is an excellent chart where he just really just summarizes everything he just portrayed in his illustration. He does excellent work when he does this kind of stuff for us. But everything I just shared and what he just showed us, I spoke it, he showed it to us, and here he's illustrated for us in a chart. So very, very good work. Thank you, George. And I believe as a believer, I think he always likes to share a message at the end of his videos, which I very much appreciate as a fellow believer in Yahuwah and the cosmology, the biblical cosmology. Let's see how much time he spends here. Okay, let's see what he's saying here. Oh, he's taking us through it quickly here. I'll just let it play because this is what we just showed in slow motion a few moments ago. He's showing it sped up so you can kind of get the idea of how the sun is moving back and forth through these portals or through these gates. Fascinating. Thank you, George. And this is what, in a moment, I'm going to show you in Stellarium, because Stellarium portrays exactly this. I mean, in Stellarium, I'll spend a moment speaking. Oh, he sped it up even more. Good. Stellarium is actual data. Oh, okay. GeoTruth, join his channel. Excellent information. So thank you, George. That was just a wonderful portrayal of the actual working of the portals according to First Enoch on a circle of the earth biblical cosmology, from a circle of the earth biblical cosmology viewpoint. Now I'm getting ready to go and demonstrate Stellarium. I don't pretend to be a Stellarium expert in any way, but it is my understanding that Stellarium, the data that is modeled is actual data. It's not modeled data. It's actual data of the movement of the celestial bodies. So I'm going to take you over into Stellarium, and we're going to be able to see pretty much what we just saw George portray. We're going to see it modeled through Stellarium here. And then I'm going to follow up with a couple of Stellarium-based models by a couple of different individuals. They are the same model, essentially. They're both Stellarium-based, and they do an excellent job of also illustrating First Enoch over the top of biblical cosmology and the Gleason map. And I'll just show you when we get there after I get done with Stellarium here. Thanks. So I'm going to try to walk you through the Stellarium process. So I've opened up Stellarium. I have saved, if you can see down here, I have saved my rough location, which is roughly Peru, Indiana on this earth. And what it pulls up is what we can see, which is pretty much nothing if you're looking at this screen right now, because it's just portraying daylight. This is not real ground and it's not real sky. It's atmosphere as they have portrayed it for us. But let me move it, because ideally what this is doing for us is it's showing me if I was standing in Peru, Indiana and looking up into the sky, this is what I could see. Well, I'm going to move from daytime to nighttime so that we could see the celestial bodies, which is what this program is really portraying for. So let me see if I can move the clock forward. Give me just a second. Oops. Okay, so I'm going to go forward in time here so that, see if I can speed it up so we can get to nighttime here and we can see the celestial bodies, because before I start moving around, I want us to see what this program is doing. Okay, all right, so hang on a minute. Okay. So it's going a little fast yet, but here what we're really seeing is this right here should be Polaris as I'm looking north. This should be the center of what we saw. There's the moon going by. This should be the center of what we saw on George's modeling. Let me see if I can go backwards a little bit because I wasn't ready for the sun to come up. Okay, let me get back to nighttime and see if I can slow it down. Okay, so I'm in Peru and I'm looking north, and here I'm to the south of the North Pole. So I'm looking north up to Polaris, the North Star here, which should be over the North Pole, which would be to the north of me somewhere here. And this is ideally what, when I look up into my sky from Peru, Indiana, this is what I should be able to see as I'm looking north. And I can turn it around. I could see if I'm looking at the west, I can no longer see the North Pole over here because I'm looking west. I start seeing things like Saturn and other things. I turn south. So, okay. But that's not really what we're trying to show here. What I'm really going to do, well, let me also, we could watch the sun go by. In fact, you know what? I am going to quickly pull this in because we can pull this down to what we see in our azimuthal field of vision. So I'm going to zoom out and then I'm going to pull it down. And this would really be what we see. This is an azimuthal field of vision or dome of vision, which I will, at the end of this presentation, I'm going to show you some modeling based upon Stellarium that we'll just get to it in a minute. But let me go forward. Let me see if I can stop doing that. Okay, let me go forward in time so that you can see the moon go by and the sun go by. And this is actual data for this time of year. This is October 17th. Actually, this is not actual data. This is projected data for the 17th because I don't think it's the 17th yet. But this is what the sun should look like as we go forward in time, and the moon as it traverses across our skies. Here's the sun coming up, traversing across the sky. This would be from the east to the west. We're watching the sun and the moon come and go each of our days. Now, I am going to back off of this. Let me go ahead and see if I can get this to pause. And I'm going to back off of this. I'm going to come back, straighten it out quickly. And let me first, I'm going to go locate Polaris because this is really what we want to go. We want to get something similar to what George was showing us, and we want to find Polaris. And I do have it pulled up, so I'm going to find Polaris, and it just did. Yeah, here it is. There's Polaris. But let me flatten this out a little bit before we go to that circular realm. And I'm going to get rid of the ground, and I'm going to get rid of the atmosphere and all the other noise that we really don't need. What is this? This is cardinal points. I don't think those are in the way, so we'll leave it on there. Planet labels we'll leave in place, but I don't need meteor showers, and I don't need satellites. And so, okay. Now I think that's all I need to remove from here. Let me also go put on, I will quickly show you the azimuthal grid, but that's not what we're going to work from. And let me also find Polaris again. So we get where it's at. Okay. So here's Polaris and here's the azimuthal grids, but I've really not found a use for using the azimuthal grids inside of Stellarium. I'm sure somebody can, but I'm going to undo the azimuthal grid and I'm going to go to the equatorial grid. And now you can see that it has centered on Polaris here. So we've removed all the land, we've removed all of the atmosphere, and ideally, and let me zoom out, ideally this would be very similar to what we just saw George portraying. Here is the North Pole. Here is the sun, and I'm going to go get back to what would have been. I can't remember if it was it March? Might have been the 19th, but that'll be roughly the spring equinox that we saw. And let me see if I can turn this, get it going south. Give me just a second here. So I paused a moment to confirm. March 19th was the spring equinox, and I did get it straightened around because I wanted to start in the southern to the south, like George did here, and I'm going to see how far I can. So that's the maximum that I can scroll out. Now, if you would remember how George started here, he didn't really show all of these grid lines here. He stopped at what would have been, I believe, let's see, this would be the fourth portal, fifth portal, sixth portal. So right in through here is where the Tropic of Cancer was. And back down here, this would be the third, second, and first portal. So back down here would be like the Tropic of Cancer. So this is how George started, and he would have highlighted or put in his blue highlights for the fourth portal, which would be demonstrated from here to here, or roughly so. It's not probably exact as what George had, but we'll be able to demonstrate the sun moving to the north through the fourth portal, then moving to the north through the fifth portal, moving to the north to the sixth portal for 31 days, turning around right here and coming back through the sixth portal, back through the fifth portal, back through the fourth portal, back through the third portal, back through the second portal, back through the first portal, turning around once it goes through 31 days of the first portal, turning around and heading back north through the first, through the second, and through the third to complete the actual year of the sun's course. So I'm not going to be able to provide the shading that George did, and I'm not going to be exact on the days like he was, 30 days. I'm going to do roughly 30 days here. And what I'm going to do is we're going to move the month. So note where the sun is here. And I'm going to go forward 1 month. And we're going to see where that sun moves to. So I'm going to go from 3/19/2024 to 4/19/2024, which will be roughly in fact, it would have to go to 4/18 because there are 31 days in March. So that would be roughly 30 days here to get to the 4/18. So the sun started here and it just moved through the fourth portal to the fifth portal. It's entering the fifth portal here. Now let's go forward to May 18th. Note where the sun is. And then we're going to go 30 days forward. And over the course of that 30 days, it has moved from here at the beginning of the fifth portal through the fifth portal. Now it's entering the beginning of the sixth portal. Now there are 31 days in May, so we're going to go to June 18th, but we're going to add a day, make it June 19th. And now we've taken, you'll notice it didn't go all the way to this line. It went to here, which if you were looking on a latitudinal grid, you would see that the cancers are both, or the tropics are both halfway between the two latitudinal lines. I don't know why that is, but that's what we're seeing represented here too. It did not go all the way to this blue line. It went to roughly here, which would represent the Tropic of Cancer. And you know what? That was going to be a 31-day month, wasn't it? Not 30. So we do need to go to June 20th because it takes into account our intercalary day. So this is the longest day of the year. This is the furthest north the sun has gone. So we started here. Let me make sure I've got this right. We start here. Then it traveled through the fourth portal. It traveled through the fifth portal. Now it's traveled through the sixth portal. Now it's getting ready to reverse course and start heading south. And by the way, it was heading from here, it was headed north. Now we're getting ready to reverse course and begin heading south. And the days this will be the longest day of the year. The day should be exactly double the length of the night here. So now let's move on to July 20th, which would be roughly 30 days. Now we've moved back to this latitudinal line, and we're now leaving the 6th. We've just gone 30 days through the 6th portal, back down, heading south through the 6th portal, versus heading north in our first traversing of the 6th portal. Now we've left the 6th portal. We're getting ready to enter into the 5th portal again. 31 days in July, so we'll go to August 19th. And you can see now we've moved back to roughly having left the 5th portal. Now we're getting ready to enter the 4th portal for 31 days now, because this is the intercalary and it's going to hit the equator line, which would be that. I didn't say it when we got started, but that first line where we started, that latitudinal line would have represented the equator. So this is roughly the equator line here. So let's go ahead and go forward and then add the 31st day for the extra day and the intercalary day. And here we are landing again back out on, we've gone through the 4th portal, and now we're landing on the equator here. And we are leaving the 4th portal and we're getting ready to enter the 3rd portal as we head south. We're back to, this would be the autumn equinox, equal day, equal night at that point in time. Now let's go forward 30 days to October 30th, and you can see, let me go back. So you can see we're leaving this latitudinal line, going to that latitudinal line, and that's the 6th portal. Or the 3rd portal that we've just gone through. So we've spent 30 days in the 3rd portal. We're leaving the 3rd portal. We're entering the 2nd portal, which is here, and it's going to travel 30 days through the 2nd portal. So let me go another 31 days in October. So we'll go to 11/19, and here we are. We've just gone through the 2nd portal. Now we've hit the end of the 2nd portal, or we're exiting the 2nd portal and ready to go into the 1st portal, which will be here. But we will not go all the way to this latitudinal line, just like we did up here in the northern hemisphere. The Tropic of Capricorn is somewhere in this area. So let's go forward. Our 30, actually, it would be 31 days, because we've got the intercalary day in First Enoch for that reaching that tropic there. So let me go ahead and go back to the 20th here. So here we are. We are now at the outermost part of the circuit of the sun. We haven't come all the way down to that latitudinal line, like I had said. We've arrived somewhere here in the middle between these two, and we've just spent 31 days headed south through the 1st portal. Now we're going to turn around, and this should be the longest night of the year, the shortest day of the year, longest night of the year. The night should be exactly double that of the day. So now the sun's going to begin to turn around and head back. So when I go to, we'll just do it. We'll go to January 20th, and we only have 30 days. So we've just left and come back to heading north through the 1st portal. We're now exiting the 1st portal. We're going to spend 30 days in the 2nd portal here, which gets us to roughly 219, we'll just say. And so we just went through the 2nd portal. Now we are getting ready to leave the 2nd portal and enter this 3rd portal, which is right here. And when we finish with the 3rd portal, we will have finished the year. So let me go back through the 3rd portal, and here we are, having completed the year. So the sun has moved through, just to recap what happened, and then I'm going to show it to you in a little faster motion if I can, and actually on a daily basis, so you can kind of watch it go. You can see the daily, because we're jumping from month to month, just like George did. So it just looks like the sun is making this large move, but it's incremental. It takes 30 days for it to run through these portals. So just to recap, we started about right here on the equinox. And we ran 30 days through the 1st portal, or I'm sorry, the 4th portal in the 1st month of the year. And then we ran 30 days through the 5th portal in the 2nd month of the year. And then we ran 31 days through the 6th portal of the year, the sun reverses course and begins to come back through the sixth portal to arrive at the beginning of the fifth portal. It spends 30 days in the fifth portal, and then it spends 30 days, 31 days because of the intercalary day back in the fourth portal, and we have finished half the year, and we have just done this our course in the northern hemisphere, and now we're getting ready to run our course in the southern hemisphere. So starting in the in the seventh month. So we had the first month, second month, third month, fourth month, fifth month, sixth month. We've just completed the sixth month. Now in the seventh month, we're headed south and we're going through the third portal. And then in the eighth month, we're going through the second portal. And in the ninth month, we're going through the first portal heading south. And then in the ninth month, at the end of the ninth month, we're going to reverse that course, pick up our intercalary day, and start heading north again. And so in the 10th month, we've headed north through the first portal. And in the 11th month, we've headed north through the second portal. And in the 12th month, we headed north through the third portal, reached the equator again, and completed our year. And we're landing at this spring equinox once again. So let me go back to, we started on 3/19 of 2024. Now let me see if I can speed up time so we can watch the sun move through the various gates. So, okay. So that might be a little too fast. Let me see if I can slow it down. Well, if we go at this speed, it'll take forever to see it. So let me go ahead and speed it up. And then just watch as the sun incrementally makes its way through this fourth gate, heading toward this line. So I'm going to speed it up, but you're going to have to kind of watch as the stars and the sun are all circuiting around our focal point. If we were on Earth, if I was roughly here in Peru, Indiana, looking north towards the stars, I'd be watching these stars and the suns coming up in the east. And they would be moving over my head, which is exactly what I see. All of these things are moving. So let me speed this up and see if we can watch the sun move through the portal. See, it's moving closer and closer to the north. It's heading north, and it's making its way through that portal. And okay, so we're only a couple days in, but you can see it happening. Let me go ahead and speed it up. Hopefully it won't be too fast. If it is, I'll slow it down again. But let's see if we can watch this. That's too fast. Yeah, that's too fast. But you can kind of, you know what? Here, of course, I forgot. I can do it this way. I can go day by day here, and let's do that. Let me see if I can get the time back to where we are south, straight, so we can watch it from the south here. And let me just go day by day here. That's what I should have done. So watch the sun move incrementally day by day now as we are heading through that third month. And you're seeing as we are approaching, we're traveling through, we're about ready to leave the fourth portal and enter the fifth portal. About now, we're entering into the fifth portal, which is what we're seeing as we watch the day. Also, you can watch the sun move, the moon move around. As you saw it described in Enoch, you see that the patterns of the moon are actually also described. I haven't really mapped it out, so I'd have to be real careful when I say this. But with a quick, just watching the moon, it seems to be acting like what we saw it moving, how it moves through the gates in a different way that the sun does. So let's keep moving through the days. Okay, so we should be approaching. See how the moon is just quickly, day by day, gone through these various portals. It's just on a different trajectory. Okay, so now we should be roughly leaving the fifth portal and entering the sixth portal now. And we're watching the sun continue to go north until we hit roughly the summer solstice, which will be around 6/19. And so we're watching the sun reach as far north as it's going to, and we're going to begin to watch it now start moving south again. And here it is coming south. Yep, here it is coming south. We're going through. We just went through the. We just went through the sixth portal. Let me back it up a little bit. From June 20th to roughly 7/20th, we're coming back south through the sixth portal, and now we're hitting roughly 7/20. We're getting ready to enter the fifth portal again, and we're watching daily as the sun moves through the fifth portal, enters roughly day 20. Now we're entering the fourth portal again, and we'll spend 31 days there because it's an intercalary month, and we're reaching the equatorial line, equator. There we are, roughly the equator, equal days, equal nights. This is the autumn equinox, and now we're going to see the sun move into the southern hemisphere and make the same kind of progression, exactly what we were seeing. And if you remember what George was showing, the speed of the sun slowed down from here going north, slowed down till it hit the summer, or uh, the summer solstice, and got to its slowest speed as it reached the Tropic of Cancer, and then sped back up as it hit the equator. And now it's going to actually speed up even more. As you remember in George's display and illustration, it's going to speed up even more as the sun makes its circuit on these outer circles. So we're going to watch this go all the way through. Notice the moon, how it's going quickly through these portals day by day. So it's not like the sun going day by. I mean, if you were paying attention when we were reading Enoch, the moon would traverse through the seventh portal in a day, or whatever it was, not the seventh portal, but the third portal, the second portal, the different portals. It would traverse through it in a day or 2 days or something of that nature. It was just a completely different circuit than what the sun is on. So, okay, so here we are going through the third portal, and we're getting ready to enter. We're leaving the third portal now, entering the second portal, and we're going through the second portal roughly. Now we're getting ready to, we just left the second portal, and we're getting ready to enter the first portal, and it's going to turn around here at the Tropic of Capricorn and start heading south again, which would be the winter solstice. So here we go. Now it's reached the Tropic of Capricorn. It's really not doing the same, it's not traveling in the same manner that it was. It's getting ready to turn around and begin heading north. And we just had our 31st day because of the month was 31 days because it's an intercalary month, and takes place as the sun is changing directions again. And so here we are with the sun headed north again. And we're getting ready to go through this first portal, into the second portal. I'm going to spend 30 days in the second portal, and leave the second portal, into the third portal, and spend 31 days in the fourth portal, and complete our year at 319, which is exactly what you just saw George portray. And I will also say that proponents of the globe model will explain that all of this Stellarium data and what we're looking for is we have flattened this. Admittedly, we have flattened this out because Stellarium can show you from a globe perspective what you would be looking at and seeing from a perspective I'm going to show you in a moment, what you would be seeing of the stars and the sun and different things. But if you flatten it out, as this would need to be on the circle of the earth, because this is the circle of the earth, and you've got a flat circle of the earth, and then you have a dome, a firmament in which the sun and the stars are placed, and they are running a circuit around the circle of the earth. So the globe proponents will share that this is, we are intentionally manipulating Stellarium data, but I will tell you that biblical cosmology folks will tell you that the globe folks are intentionally manipulating the data, because this would be the true data, and they're able to manipulate it in Stellarium so that it wraps around the globe, around a round spinning Earth globe, and they can make it portray. And that is a truth. I mean, I've heard it, and if you Well, I'm going to head off to something in a moment, and I'm going to show you the two competing methodologies and the two competing thoughts on this. The globe proponents will say that the flat Earth proponents, or the we like to call ourselves biblical cosmology proponents, founded Earth proponents, are taking data and flattening it out. We're taking the globe data and flattening out, manipulating the data. Well, we're going to say biblical cosmology will say that they're taking the flat Earth data or the founded Earth data and wrapping it around a ball. And George has on his website some work associated with that as well. I'll let you all visit his site to see what he has to say. Very interesting data. So, okay, let me wrap up Stellarium here, and then I've got one more thing to show you. Okay, so I would like to show you the flat Earth dome model that was put together by a Walter Bislin. And this is his website. And he is a globe proponent. And all of his work and his writing, if you read all of his intro and his notes and his information, he's pretty much obviously just believes that the world is a globe and and that the data that he's getting ready to show us models a flat Earth, but it can't really be a flat Earth. So you could, if you wanted to, you could go to his site and you could read all of what he writes and what he says, and he argues for the globe and against those of the flat Earth camps who would, argue in a different manner. But I would leave all that to you. I don't really want to get into the arguments with them. But I'm getting ready to go off to this Shane Pierre. He has, when I first started looking at this flat Earth dome model and evaluating it for my purposes, this all read differently, and he's since updated it, and he's addressing because Shane St. Pierre, and I think he also there's a Austin Whitsitt that he'll also reference because these are two folks that are have utilized this flat Earth dome model and spoken of it in a different way. In fact, I'm going to quickly go ahead and go to Shane St. Pierre's model here. This Shane's flat Earth dome model, which is really what he's calling his Shane's flat Earth dome model. And he's getting ready to show us pretty much the same model. Now, I believe Walter Bislin and his folks developed it first, and Shane has taken that work and developed it further. Maybe not further, but he is also utilizing the same data. But he's introducing, and you can see there's an argument between them, Shane, St. Pierre, and folks on the flat Earth side against Walter Bislin on the globe side. And you could tell by the write up here, if you look at Shane's introductory notes and write up, he's addressing Walter Bislin as he goes into the flat Earth dome model. So I'm going to come back to St. Pierre, his model here in just a moment, just because I want to use it. And but I'm going to go back to Walter Bislin's model for just a moment. And you can see it pretty much looks the same. But I'm going to explain. Well, actually, I am going to go back to Shane's website to do this, to explain what we're looking at here and what we're looking at here. So I'm going to just acknowledge that Walter Bislin has this model, and he originated it. He's got his own write-up and his own opinions of what we're seeing here. He basically, even though he has superimposed Stellarium data on the Gleason map, he doesn't believe this can possibly represent what's happening in the world. So, but I'm going to leave here, having acknowledged Walter, and I'm going to go to Shane's model, and I'm going to illustrate from Shane's work here. So what we're looking at is, if you're familiar with the Gleason map, there's a Gleason map that is a flat Earth map. It is an azimuthal grid map, I believe they would call it. And you can see you've got now we've got the land masses inside of the oceans here.
on a flat Earth, and then on this white around the outside would be the Antarctic walls, like we were talking about when I was talking and working with George's circle of the Earth illustration here. And that's what you're looking at here. This would be, in biblical cosmology, the circle of the Earth. The Earth is a founded Earth uh, of a circular nature, surrounded by what would apparently be an Antarctic wall. I mean, the Bible doesn't necessarily say that, but that's what we see as we go to the outer rims. And we have here this, looking at this, you've got so to just go back, this is in the light blue and the white and the green. This is the Gleason map that we're talking about. Then we see the latitudinal line superimposed on over the top of it, and we see this is the sun as it would be circling. And we're going to show it here in a minute, but it would circle around. Um, sorry, I'm having trouble with my mouse here. It's going to circle around the globe. And I want to make a quick comment here because of a question somebody asked me before. These latitudinal lines, help us to gauge, the position of the sun, but they aren't necessarily representative of the exact portals. I doubt that those latitudinal lines and the distance between the two, which is what, 60, I'd have to think about it, 60 degrees, 62 degrees, something of that nature in that certain distance. Well, that's not necessarily the size of the portal, but it does give us references, a way to kind of gauge the movement of the sun as it moves back and forth in the circuits. Just gives us a way to reference it, but it doesn't necessarily mean that those latitudinal lines are the exact portals. In fact, I would doubt that they are. So, let me see if I can explain a little bit further here. So we've got this time. All these are all the inputs that go into this map, and we've got this time, and I've got it set to 12 o'clock on this map, wherever it is. I'm not sure what time zone this 12-hour is, but at that time, it places the actual sun here on the Earth in this model. Now, I've also set the day of the year to day 78, which would roughly be the equivalent of the spring equinox in 2024, 78 days into the year. I believe should be right around 319. And then we're looking at the observer latitude, which would be these lines going out. And I have set the latitude to Peru, Indiana. And I will also, let me quickly point out, here's where this is the observer point of view. This is where the view is originating from. And that is the result of these longitudinal and latitudinal lines. And I've used the longitudinal lines of minus 86 degrees. And that places me pretty much in Peru, Indiana. So this is roughly 40 degrees latitude and minus 86 degrees longitude. And that gets us at Peru, Indiana. So that places at this little X, and my point of view here at Peru, Indiana. And so I'm looking at the world in this sphere or dome of observation from Peru, Indiana. And then let me quickly just finish up a couple things here. We've got a camera direction, camera height, and you can see if I change the camera direction, it changes where I place things. And if I go to the camera height, it basically kind of, it zooms out, it actually flattens out because it would be following along the the dome, what should be the dome. Here, I'll just show it to you real quick. So if you were to turn it sideways, you could see, and let me get pulled back up here. You can see that it's portraying this dome, and this is biblical cosmology for at least let me rephrase that. This is the prevailing theories of biblical cosmology. I think many of us, I believe, many of us will adhere to this, but not everybody does who believes in a flat earth and just acknowledges that the the things we see cannot really necessarily be represented on a globe earth, so they believe in a flat earth with other models and other theories to explain the flat earth. But this seems to be very representative of what Enoch would show us. So we flattened out the flat earth. So we've flattened out the Gleason map here. You can see the water, and here's the the Antarctic wall here, and here's Peru, Indiana, here are the land masses, and we flattened it out so that you can actually see the dome ideally rising from the outer walls, which, here it's presuming it would be somewhere in the Antarctic here. And the dome, the firmament rises here and forms a dome, or um, the firmament. I won't enter those conversations. And here is the height in that dome. And if you remember what George was sharing, this it was, I believe, it was 3,107 miles all the time. So we're going to watch this sun go around inside this dome and never change the height from the Earth to the sun, because it's just in this, it's where it's at in the dome. It doesn't change height from here to wherever it's going. Um, and George, I've seen George's work where he's establishing the height, and I don't argue with him. I just don't argue with him. I think he's probably correct, certainly inside of this model. And I would like to also quickly, and I'll do it from this perspective here real first. From Peru, Indiana, I cannot actually see that far. It's not possible for my eyes to see that far. And that's why many of the folks, the globe Earth folks, will question what everybody is seeing, as though we should be able to see the sun and these distances from here to the outer walls, and the sun, what is that, 30,000 miles, a long way away from where I would actually be. And that's just outside of what our eyesight can see. But what we're seeing represented inside this outer dome here, or the actual dome of or the firmament of the Earth in this model, is an interior dome, which would be this azimuthal grid of vision, or field of vision. This represents what we actually can see from our perspective. I can't see the sun clear out there. From my perspective, I see the sun here. And if I pull, in fact, I'll just show you from here. I'm going to show you again from a different perspective. This is probably outside of what I meant to do today, but I'll show it to you just real quickly. As I go forward in time and we see the sun coming around, the sun is coming, around and traversing from clockwise. So it's moving from here. It's going to move around here. But what I actually see is not this. I cannot see this. What I actually see from here is what's going to be portrayed in this dome of vision. So I see that as the sun is approaching, what I see is the sun rise from my perspective. I'm sitting here looking east, and I'm seeing the sun come up, and you're going to watch the sun, not in actuality, but in what I could see, follow this yellow line within this uh, field of vision. As the sun moves across the dome, you're going to see a solar noon my time. Clearly, 12 o'clock solar noon. 12 o'clock was not solar noon my time here, or the sun would have been here and here. But when it does reach noontime, the sun will be straight up above me right here, and in the actual dome above us, it'll be also straight up above us and heading off to the east. Now, what we observe, we'll see sun speeds, and the sun speed moves at a different speed here, because that is a shorter distance than what the sun must actually be moving, and what George modeled or showed us in his work. The actual sun speed required as the sun moves in and out of the various portals. But that's not how the sun is observed in Stellarium. The sun will be observed on this shorter radius here, just a shorter path. So it just doesn't have, when you measure time and distance, you will not come up with the same speeds. I believe that if I remember right, at the equator, and when you're measuring in this field of vision, the speed of the sun is right around 1,072, something like that, miles per hour. Whereas it's going much faster, according to George's work. And really, I've got another gentleman who has also mapped out how fast the speed must. A gentleman who favors the globe model, who has mapped out this data for me as well, and confirmed that the speed of this sun actually moving is much faster up in the actual dome than what we can observe here. And what you can observe here, this would also be, if you look at this looks like half of a globe. And because this is what we see modeling, this is the argument. This is what Walter Bislin and globe folks will say. This is what's actually happening, because you've got a globe about this size compared to half a globe anyway, about this size compared to what you would see in this, in the flat Earth being flattened out. This is what you'd be seeing, and this is they've got in the globe model. They've got this spinning around an Earth, a sun, a stationary sun over here, and the globe is moving. Whereas in this model, we're still showing a spherical dome, which they're saying is a globe. We're not saying that the world is a globe. We're saying that what we can see is a dome of vision here. And as the sun moves across, and the moon, because here's the moon, there it's also mapping out the moon. Here's the actual moon running through the gates. You're going to see it here. It's represented here in this green line. But as we move forward, you're going to watch, and I'll show you here, watch this sun rise here and move across my sky. And that's what it looks like. But the sun is actually moving on its circuit up here across me, but it looks like it's rising above me and rising to my right, coming above me and setting to my left. So let me just move the time forward and watch the sun go by, and see the sun in the dome rising above my head there. And again, just to reiterate, I'm here and this is what I'm watching, but here's where the sun actually is. And as the sun moves by, here it's approaching solar noon. For me, right about there, roughly, is solar noon, where the actual sun and what I can see of the sun are both straight up above my head here at this day of the year. And then it moves past me, and the sun stays on a horizontal path going around its circuit, but in my field of vision, it is setting to my left and going down. Okay, let me go ahead and return to a camera height above here, and so that we can look down. And what George illustrated and what I actually illustrated on Stellarium is, while I'm here and looking north to see that this would be the North Pole up here, and I have to look north to see it, and I have to look north to see the star Polaris, the North Star up here. I have to look north to see it. But from this perspective, I'm looking straight down on the. If I was standing above the dome, I'd be looking straight down on through the North Star to the North Pole on the Earth here. If I was looking down at the Earth and looking up, like it would appear to be if we were on Stellarium looking up, that represents what it would be if we were on the Earth looking up. This is what it would look like as if we were above the Earth looking down. Okay, so in this illustration, I have moved the day of year to 78, which is should be right around the spring equinox. I'm going to go back to 12 just to get my sun position so we can watch it better. So here it is, because I want to watch the sun move across these latitudinal lines so that we can see, because this is what how the portals and the gates are being represented as we go through these gates. So here we are at the equator. The sun should be right above or right around the equator here, and it's circuiting as it goes around. It's circuiting around the equator here. So this latitudinal line should be of the sun should be 0 degrees latitude, or the equator. Let me go back to noon or 12 o'clock here. And what we're going to watch here as I go forward in days, we're going to watch the sun move towards the north through the 4th portal, through the 5th portal, through the 6th portal, and reach what would be roughly that would reach in reality, would reach what is called the Tropic of Cancer. So it reaches the tropic, which is where the sun turns around and begins heading back, travels back through the 6th portal, through the 5th portal, through the 4th portal, hits the autumn equinox again as it gets ready to move into the southern hemisphere. By the way, all of this to the north of the equator is considered the northern hemisphere. Everything to the south of the equator is considered the southern hemisphere. And in the first 6 months, we're going to watch the sun move through the northern north through the northern hemisphere, then south through the northern hemisphere, and then enter the southern hemisphere, going south through the third portal, through the second portal, through the first portal, reverse its course at the Tropic of Cancer, and begin heading north through the Tropic of through the the first portal, and then the second portal, and then the third portal, to come back to its origination and complete the 364-day year. So let's see if we can illustrate this. I won't be able to as easily do, well, yes, I can. But let me first, before I come back, I'll come back to the 78th day and we'll watch it. But let me first move forward. Roughly, if the spring equinox 319 is day 78, then 30 days later is roughly 108. So let me just watch where the sun is at now on the equator. I'm going to punch in 108 days, and you'll see the sun move in through what would be essentially, it just traversed the fourth portal and is now at that. And you can see it's not lining up with that latitudinal line here, and it doesn't have to. That's not what we're trying to observe. We're just using the latitudinal lines for a point of reference. So that was 30 days in, and that's how long it takes to traverse the fourth portal. So now I'm going to go 30 days in again, which would be what, 138, day 138. And watch the sun move. There, it's moved in through the fifth portal again. 30 days later, now we're going to go 31 days through this third month to get us to, that would be 169, to get us to the Tropic of Cancer. And there it's moved. You can see it did not move quite as far. The sixth portal does not appear to be as larger portal as the fourth and fifth portal. It went halfway through these latitudinal lines. Now it's going to, and I'll show you when I go day by day here in a moment, it's going to reverse its course and begin heading south again. So 169 plus 30 days in the fourth month is 199. Now watch, the sun's heading south. There it goes again. There it goes south. And then 30 days later is 229. And there it's moved out through the fifth portal. And now it's entering into the fourth portal, where it will spend 31 days and get us to day 260. And we should again be on the equator, the autumn equinox, equal days. The sun is traversing over the top of the equator, in the middle of the southern and northern hemispheres. And we have equal days, and now going forward, we're going to enter the southern hemisphere, where the night becomes longer and the day becomes shorter. So added 30 days, and now we're also leaving the fourth portal and going for the first time into the third portal, and we're going to spend 30 days in the third portal. So that's going to get us to day 290. And so we just watched the sun go through the third portal. Let me also point out something that I didn't point out earlier. In this modeling also, you can see the sun's effect, the modeled daylight, which George also speaks of this in some of his videos, the daylight hours required. I'll let him do that discussion because it's a big discussion. But you can see that the portion of the night and day shadowing on this model as well. So anyways, we just went through the third portal. We're going to go through the second portal now, and we're going to spend 30 days in the second portal. So that gets us to day 320. And we just went through the second portal. Now we're entering into the first portal, where we will spend 31 days traveling south for intercalary day. Oops, I'm sorry. I must have already. No, I've got the wrong. Let me go. This would be 320. 351 is what I meant to put in there. I'm sorry. Let me go back to, I'm going to quickly go back to day 320. I had a little trouble here. 320. So that's where the sun was as it's entering into the first portal for the first time and still heading south. And then we go to day where it will spend 31 days in the first portal, which gets us to day 351. And there it is, moving south, where it will turn around now and spend 30 days heading north through the first portal. And then that gets us to day 16 in this day of year that we've got to use as it's heading south. or north, I'm sorry. So there it is moving through the first portal. 30 days later will be 46 as we travel through the second portal again. And now we're going to spend 31 days in the third portal, which should get us to 77 days. And here we are back at the equator again, and we've just completed the year illustrated on this spherical model, or what Walter Bisson would call a flat Earth dome model. Now, let me see if I can illustrate this day by day for you a little better. And we can do that by hopefully here. So I'm at day 78 if you're seeing here, and I'm going to use my up arrow, and it should take me through day by day. So I'm gonna try to move fairly quickly through so we can watch the daily movement of the sun. So here we go, day 79. Okay, so you can see the sun moving towards the north, and you can watch the pattern and the movement of the moon. I'm showing you the moon here. You can also watch this, just what we saw on Stellarium, and how the moon moves differently. While it goes through the same portals, it moves differently through the portals. So let's keep moving forward to the north. And when we get to the what would be the summer solstice here, the longest day where the sun's turning around, watch the sun. Watch where the sun, how the sun, in fact, we're getting there. See, the sun is moving. Let me back up here. The sun is moving kind of north on my map here, but watch when it starts to turn. It actually kind of starts heading up. See it heading north, and now it's going to begin reversing its course and reversing and going back. Did you see that? This is Stellarium data superimposed over the Gleason map in this model. So this is actually happening as the sun is reversing its course. See, I'm going backwards in time here, but you can see the sun is making this movement. It's not just stopping and heading back. It actually moves up and then starts heading back. I think that's very interesting. And I'll also quickly address right here before I get going. We know that according to all of our information, that the actual length of time it takes to move from the spring equinox to back to the spring equinox is the 365 days and some change, like 365.25 days, something like that. And we know there has to be some reconciliation between Enoch telling us it's a 364-day year that takes us through these portals and lands us back where we started from. And I know that many people who are working on the calendar have their methodologies to add intercalary days, intercalation. That's required. That's why we have the leap year. Everybody's trying to accommodate what we're actually seeing, or at least what we're being told that we're seeing for this 365 day 365.25 day year. And there must be some sort of, or we perceive anyway, and I want to be careful because I'm not sure. I mean, this is Yahuwah we're talking about. And if he says that the year should be 364 days, but it doesn't match up with what we see in the celestial bodies, that's for him to reconcile. If he does something with the celestial bodies to make sure that our seasons don't get out of whack because we're observing a 364-day year, when the sun actually takes 365.25 days to make it a complete annual circuit to return back where it started from, well, that's Yahuwah's. I don't want to call it his problem. That's his creation. I'll leave that to him. I mean, he's in charge. He told us in Jubilees and Enoch, and he told us 364 days is the year to be reckoned. And if we don't reckon that way, all of our feast, all of our days are going to get out of whack. And that's what's happened today. Nobody really knows. I think it's coming back when we are going to begin to learn and know again, so that we can celebrate the feast days and the special days, the Moedim, with the appointed times with Yahuwah and the messengers of the angels in the Shemayim in the skies with them again. But right now it's out of whack But I recognize that 364 days is the Enoch year, the Jubilees year, whereas the actual year from what we're told and observed seems to be 365.25 days. But I can't address that here, and I wouldn't know how to address it. I know folks dealing with the calendar are coming up with the Zadokian calendar, and some of the other calendars are having to come up with other means and ways to find intercalation to rectify those days and keep our seasons intact. Different topic, different story, but I thought I'd address it quickly because it's come up in some of the conversations I've had with regard to the movement of the sun and the 364-day year of Enoch. So let me keep going here. So as we go through the year, day by day, we're watching the sun traverse, and now it's going to head south again, back towards. Now we're going south through the northern hemisphere towards. We just probably went through what appears to be the fifth gate. We've entered the fourth gate. We're going through the fourth gate. We're hitting the 31 days. We're hitting the equinox again, sun over the equator. But now the sun is moving out of the fourth into the third portal, going south. He's in the southern hemisphere for the first time, heading south. Now he's going roughly through the third portal and entering into the second portal. And see if I can keep going here. And we're traversing through the second portal, headed towards the first portal, where it's going to turn around, which it just did. You see it? It did in the same way that it did it in the north here. It didn't just turn around; it goes north and then starts heading back that way. So watch that activity. And there it is, going back through the first portal, headed to the second, through the second portal, back to the third, and now headed towards through the third portal back to where we basically begin. Now I'm going to, and I'm pretty much done here, but I would like to briefly address the day to night ratio that Enoch also discusses. So I'm returning back to Shane's model, and I've come back to the spring equinox around 319, which would be day 78. And we're going to start with at time of 12. I'm not sure what time zone that is. And I'm staying with the observer latitude of Peru, Indiana, which is roughly 40 degrees latitude. But I'm pretty confident that the ratio of day to night would vary by your position on the earth. And I'm not sure where Enoch was observing from. I know Jerusalem. I'm not saying he was in Jerusalem or even in Israel when he was looking at this. But Israel's roughly 31 degrees latitude, so a little south of us here. But I'll be able to illustrate what's happening here, I believe, in the northern and the southern hemispheres. I believe, and it's this modeling represents what Enoch was sharing with us. So here I am. I'm back at the spring equinox, day 78 of the year, which should be around 319, and I'm just going to start at 12, whatever time zone that is, but it'll get the point done for us. So here we are. If at hour 12, when the sun is in this position, we are in daylight here. And if I go 12 hours forward, equidistance, and now I have just lost the daylight, but it's roughly an equal day on this day of the year. If I move into, we'll just go 30 days forward, but it's, and let me also say in the southern hemisphere, it also appears to be roughly the same, because if we are, well, here, let me just, if we were in the southern hemisphere and down on the southern tip of South America here, the day is also roughly, we add 12 hours to 22, which would be what, 36? So it's roughly a 24-hour day. Maybe I did that wrong, but it's roughly a, let me go back and we'll just look at it. Southern tip of Argentina. Here's where the day would begin at 10:39, and here's where it would end at 22:25. 12. Okay, so 12 hours later. So roughly in both hemispheres, it appears to be roughly half daylight, half night at both equinoxes, in the spring and autumn equinox. But if I move to, we'll go back to 12. If I move to day 108, which is 30 days later, what we see is the daylight, as the sun moves north and its impact of daylight is actually shrinking, and you would think that, well, that would cause the night to be longer and the day to be shorter. Well, that is true in the southern hemisphere, but not in the northern hemisphere because of the positioning of the sun. So if I were to start at, let me just go back to, here's where the sun is coming up at 11:16, and we're watching the sun from my perspective where I'm at. There it's going down at 23:61. So 30 days in, now the day is longer than the night for me in the southern hemisphere. Let me go to day 138, 30 days later. And while the sun has moved north and the influence of the light has shrunk and the shadowing has gotten bigger, probably not so for me. So let me go back to where I'm at. Daylight, here's daylight at roughly 10.82. And then let me go to nighttime. Here's nighttime at 10.82. So we're at 24:40. So roughly that's almost 14 hours of daylight now at that time of year for me in the southern hemisphere. But let me go back to the southern tip um, of South America here. Their sun's coming up at 12:35. I'm expecting their day to be shorter uh, in their winter, which is summer for us, but winter for them in the southern hemisphere. Their days are getting shorter, so we're watching the daylight start at about 12:35 at the southern tip and ending, what is that? 20.18, so 8 hours, 14. Yeah. So it's a shorter day in the southern hemisphere, but a longer day for me. Now let me go to what would be roughly the summer solstice, the longest day of the year, roughly, which should be right around day 169, 170 in that neighborhood. And let's go back to the day. So the day is starting for me at roughly 10:58, and now it continues through 24:60. So basically a 14-hour daylight period, which is the longest day of the year for us. But watching in the southern hemisphere again, day starts at 13:39, ends at roughly 1969. So that's actually the shortest day of the year for the folks in the southern hemisphere at the southern tip of South America. Now let me move forward. Let me go back to 12 as my hour, and then let's go to what would be. Well, let's go to the. Let's just go straight to what would be the winter solstice for us, the shortest day of the year, and we'll just compare that. So that would be around day 355. Okay, so again, the sun is in the southern hemisphere, and by appearances on the Gleason map, it is. In fact, you can see it's actually completely engulfing the sunlight going around here. It's actually engulfing the um, the shadow, and this is why we get 24-hour. You could say easily that in the Antarctic, in the southern hemisphere, they get 24 hours of sunlight, because at this time of the year, the sunlight is actually still wrapping around in this modeling and engulfing the shadow of that day. And this would be in their time, their summer solstice, their longest day of the year. And let's just go follow them both. So Let me see if I can get back to where my day starts here. So I'm not even going to be able to do it from there. Let me go here. So here's my day starting at hour 12-ish, 49. And then even though there's a lot of sunlight, the way this shadow works around, it comes and hits me again at 22:45. So my day runs from 12:87 to 22. So roughly a 10-hour day, which would be roughly the shortest day of the year if I'm doing this correctly for me. And in South America, if we were looking at South America, their day starts here at the southern tip here. Their day starts at 8:10 in the morning, but it runs all the way through to 24:64. So that's their longest day of the year. So what we're seeing is the modeling showing the, Enoch, in Enoch's discussion of, how many parts of day there are in the first 6 months and how many parts of day and night there are really in each month of the year. It also seems to agree with the modeling we can see here using Shane's model and this uh, the Gleason map and what we can see from Stellarium. So in closing, I would like to introduce a little more video from George that I came across as I was finishing up this video. And I would like to make a quick observation that George Newber's work, is based upon information he obtains from the United States Naval Observatory related to the movement of the sun and uh, just various data associated with the sun. But he created a video called that he entitled "Video Number 11: Sun's Gates," where in the beginning of the video, in the first 5 minutes of the 8-minute video, he is basically reading for us and giving us the data from First Enoch that is demonstrated and illustrated in the work he's doing, which is what I've done in this work also. But in the last 3 minutes of this video, he does a wonderful job of illustrating this for us once again. So I'd like to close out with his video. And so here we go.
Next, we will see the sun traveling north and south for a full year, which is based on the navigational data from the United States Naval Observatory and is exactly as described in First Enoch. Each gate described in First Enoch is the latitude distance the sun travels north or south for a duration of 1 month. For each month, the latitude location of the sun is shown at day 1, day 10, day 20, and day 30 or 31. The sun travels north in gate 4 during month 1, which has 30 days. The sun travels north in gate 5 during month 2, which has 30 days. The sun travels north in gate 6 during month 3, which has 31 days and the summer solstice. The sun travels south in gate 6 during month 4, which has 30 days. The sun travels south in gate 5 during month 5, which has 30 days. The sun travels south in gate 4 during month 6, which has 31 days and the fall equinox. The sun travels south in gate 3 during month 7, which has 30 days. The sun travels south in gate 2 during month 8, which has 30 days. sun travels south in gate 1 during month 9, which has 31 days, and the winter solstice. The sun travels north in gate 1 during month 10, which has 30 days. The sun travels north in gate 2 during month 11, which has 30 days. The sun travels north in gate 3 during month 12, which has 31 days, and the spring equinox. Here is a quick recap of the gates throughout the 364-day year.
Thanks again, George. And thanks for spending time with me today. And may you be Baruch.